Welcome back to This Explainer, everybody. Today, we are diving into a true historical medical thriller. We're going to be tracking down a pathogen that has literally plagued humanity for centuries. It's a microscopic villain so incredibly notorious that it actually earned the title as the mother of all sore throats. We're going to break down exactly how this disease operates, how humanity finally fought back, and why it remains such a fascinating and frankly terrifying subject of modern medical science. Let's get right into it. Okay, to really understand this, we need to establish some baseline context. Look, everybody gets a sore throat, right? We've all dealt with those annoying common cold viruses that cause pain and redness. And a lot of us have even experienced strep throat, which brings those awful enlarged tonsils and pus. And yeah, while a normal viral or strep infection can absolutely knock you off your feet for a few days, it's usually over pretty quickly. But diphtheria? Oh, viral and strep infections completely pale in comparison to this one. This isn't just a bad cold, folks. This is a historical plague with serious lethal potential. Section 1. Profiling the villain. Corynebacterium diphtheriae. Let's officially meet our pathogen. It's a rather nondescript little gram-positive rod called Corynebacterium diphtheria, but the etymology here, it is absolutely fascinating, mostly because it perfectly foreshadows the horror of the disease. Corynebacterium comes from the Greek word koryne, which means club, and that's because under a microscope on a gram stain, this bug actually looks like a tiny club. The second part, diphtheria, comes from the Greek word diphthera, which translates to leather hide. And as you'll see in just a minute, this chillingly describes the thick, suffocating web that the disease forces to grow right over the human throat. Now, much like tetanus and botulism, the real danger of diphtheria doesn't actually come from the bacteria itself. It comes from a toxin released by the bacterium. But here's where we hit a massive biological plot twist. Strains of this bacteria that do not produce this specific toxin are totally avirulent. They're basically of no consequence and are completely unable to cause infectious disease on their own. So that begs the question, if the bacteria alone can't cause the disease, who actually makes the deadly toxin?
Are you ready for the shocking answer? It's the betaphage virus. Yeah, the crazy truth here is that the bacterium itself does not produce the diphtheria toxin at all. The toxin is actually the product of a virus that invades and lives inside the bacterial cell. This betaphage virus literally hijacks the bacterium, incorporating itself right into the bacteria's genome. So as the bacteria goes about its normal life copying its DNA, the viral toxin is produced and escapes. Basically, the bacterium just settles into your throat doing its normal thing, while the virus inside it manufactures a deadly poison. The result for the infected human is absolutely disastrous.
And this actually brilliantly illustrates how this toxin functions. You know, microbes often make chemical compounds to destroy their competition. Take penicillin, right? That's a mold making a compound that stops bacterial growth, which we then use as an antibiotic. Well, the diphtheria toxin works like a reverse antibiotic. The microbe makes the compound that acts as an antibiotic against us, against humans. Just like certain antibiotics shut down protein synthesis in bacteria, the diphtheria toxin targets and completely inhibits protein synthesis in human cells. And obviously, shutting down human protein synthesis has incredibly fatal consequences. Section 2. The attack, the creeping crud. Because the organism colonizes the throat, that is exactly where the toxin gets highly concentrated. And it begins innocently enough. Diphtheria spreads through respiratory droplets from coughing and sneezing, just exactly like a cold. For the first 2 to 4 days, it even mimics a common cold. You get a scratchy throat, some nasal congestion, maybe a low-grade fever. But step 2 happens really fast. A thick white coating appears over the tonsils and the uvula. And in just another couple of days, we hit step 3. This white creeping crud spreads over the entire throat area and turns into a dark, ugly gray mat. This is known as the pseudomembrane.
And this pseudomembrane is the hallmark of the disease. It presents the most immediate, terrifying danger because it can literally clog your respiratory passages and lead to suffocation. Remember that leather hide we mentioned earlier? That's what this is. It's a thick, tough web of dead cells killed by the toxin, mixed with fibrin, dead blood cells, and whatever else gets trapped in its path. It's an immediate, lethal threat, particularly to young children, because it physically works its way down into the larynx. If it breaks off, they suffocate. Historically, surviving this meant you desperately needed access to good medical care, like a respirator or a tracheostomy, to physically force open a breathing passage. In poor or rural areas without those options, the outcome was almost always tragic.
But here is the really crucial point. While that choking pseudomembrane is horrifying, the diphtheria toxin doesn't just stay in the throat. It gets absorbed and unleashes a massive systemic attack across the whole body. Outside the throat, it zeroes in on the heart,
the nervous system, and the kidneys. Early on, it attacks the nerve cells around the head, basically paralyzing the nerves you use for breathing and swallowing, which makes choking on that pseudomembrane even more likely. And later, it attacks the heart, causing significant damage that unfortunately frequently results in death.
Section 3, Catching the Killer, Beating the Microbe. Thankfully, humanity didn't just surrender to this historical serial killer. Science fought back. Our triumph began way back in the 1880s when scientists finally discovered the organism and proved that a toxin was responsible for these horrible symptoms. Fast forward to the early 1900s, and we get our first real glimpse into immunology. Doctors figured out they could take healing serum from a person recovering from diphtheria and give it to a recently sickened person to drastically lessen the disease's blow. And then, the monumental breakthrough. In the mid-1920s, around the same time as the tetanus shot, a vaccine was developed using a safely modified version of the toxin itself. It's an incredible achievement, and it is the exact reason why diphtheria is such a rare disease in the developed world today.
Section 4. The false positive, diphtheroids. Okay, I want to bring up a quick point of lab report confusion you might actually encounter today. If you're ever looking at a clinical lab report and you see the word diphtheroids, please do not panic. These are completely harmless. See, there are tons of benign species of this bacteria family that just live as normal microbiota on our skin and mucosal membranes. But remember that weird club shape we talked about? Well, these benign skin bacteria tend to clump together in those exact same bizarre shapes under a microscope. Because they visually resemble our deadly villain, the medical term diphtheroid was coined. Finding them on a lab test just means some normal skin bacteria bumped into the sample. It absolutely does not suggest the presence of the deadly pathogen.
Section 5, A Lingering Mystery.
As we wrap up this explainer, there's actually a fascinating biological cold case here that remains totally unsolved by modern science. We know the modern vaccine doesn't target the bacteria itself, right? It only targets the toxin produced by that hijacked virus. So, theoretically, harmless, non-toxic strains of this bacteria should still be able to happily colonize our throats. The vaccine shouldn't bother them at all. But that is not what happens in the real world. Toxin-negative strains are almost never seen. For some completely unknown reason, strains that don't make the toxin just cannot compete with the other normal bacteria in the human mouth. They just can't gain a foothold. Why this happens is still a total mystery. But hey, it heavily works in our favor by keeping carrier rates incredibly low.
Which brings us to a chilling final thought. Could diphtheria make a comeback? I mean, think about it. In its absolute heyday, this disease wasn't an annual thing like the flu. Sometimes 20 years or more would pass between recognized massive epidemics. The crucial takeaway here is that this pathogen hasn't vanished from the earth. It is still very much alive in less developed parts of the world. And because it's still out there waiting, a drop in adequate early childhood vaccinations is really all it would take to invite this monster back for a brand new epidemic. It is a stark reminder of the fragile, ongoing victory science has achieved over the mother of all sore throats. So what do you think? Are we doing enough to ensure this historical killer stays in the history books? Keep learning, stay curious, and thanks so much for joining me for this explainer.